Hidden in a patch of sky no wider than a grain of sand held at arm's length, there is a faint red smear that has no business being there. It is not impressive to look at. On the raw data, it is a handful of pixels, a whisper, the kind of signal an astronomer would normally dismiss as noise or a defect in the detector. But that whisper left home when the universe was still an infant. It has been falling toward us for 13.5 billion years, sliding across space that stretched underneath it the entire way, bleeding its color out toward the infrared until it was barely recognizable as light at all. And when it finally landed on the gold mirrors of the James Webb Space Telescope, it brought a problem with it. Because this galaxy is too bright, too small, too chemically finished. It looks like something that had already been running for a long time, at a moment when nothing was supposed to have started yet. Its name is MOM-Z14, and the people who found it have been arguing about what it means ever since. To understand why this object is so unsettling, you have to understand what the universe looked like before there was anything to look at. Light moves at roughly 300,000 kilometers every second. That is the hard ceiling of reality. Nothing overtakes it. And yet, space is so absurdly large that even at that speed, a photon can spend more time in transit than the Earth has existed. The universe is about 13.8 billion years old. But for its first few 100 million years, there were no galaxies. No stars, no planets, no chemistry, no light worth the name. Just a thick, warm fog of hydrogen and helium expanding into the dark. Astronomers call that stretch the cosmic dark ages, and the name is literal. The fog was opaque. Photons could not travel freely through it. Even if you had been floating in the middle of it, with your eyes open, you would have seen nothing. Then gravity did what gravity does. The fog began to clump. Denser knots pulled in, more gas collapsed, heated, and eventually ignited. The first stars switched on, and they were monsters. Enormous, violent, short-lived. Their ultraviolet output tore through the neutral hydrogen around them and stripped the electrons off it, burning transparent bubbles into the fog. The bubbles grew. The bubbles merged, the fog lifted. That transition is called reionization, and the moment it began is what astronomers refer to as the cosmic dawn. Every single telescope pointed at the deep universe is, in one way or another, trying to catch that sunrise, and every year we manage to push the observation a little closer to it. Until very recently, the crown for the most remote galaxy ever confirmed belonged to an object catalogued as JWST 14-0, also pulled out of the dark by Webb. Its redshift was measured at 14.18. Redshift is simply how much the expansion of space has stretched a wave on its way to us, and it functions as a clock. A redshift that high meant the light had departed when the cosmos was roughly 290 million years old. That was already at the edge of what anyone expected to find. Then a group working out of the Kavli Institute at MIT went digging through Webb imaging that had already been collected, looking for candidates that everyone else had passed over. They found one. An object that showed up clearly at longer infrared wavelengths and then simply vanished at shorter ones, the exact fingerprint of light that has been redshifted so severely that the blue end of it has been erased entirely. It was suspicious enough to be worth telescope time. In April of 2025, they aimed Webb at it directly and ran the light through the NIRSpec instrument, which splits a beam into its individual wavelengths, the way a prism splits sunlight into a rainbow. That is how you stop guessing and start measuring. The spectrum came back at a redshift of 14.44. They named it MOM-Z14, and with that single measurement, the record fell. We are now looking at light that departed its galaxy about 280 million years after the Big Bang, when the universe had lived through roughly 2% of its total lifetime so far. Try scaling that. Compress all of cosmic history into a single calendar year. The Big Bang happens in the first instant of January the 1st. This galaxy is shining by January the 7th. The dinosaurs do not appear until the day after Christmas. Every human being who has ever lived fits into the final few minutes of New Year's Eve. And somehow we built an instrument, launched it 1.5 million kilometers from home, and caught a photon from the first week of January. Here is where the trouble starts. MOMSI 14 is tiny. Its light spans something like 240 light-years across. The Milky Way, for comparison, stretches about 100,000 light-years from edge to edge. We are talking about a structure hundreds of times more compact than the galaxy we live in, closer in scale to a single star cluster than to a galaxy at all. And it is fierce. Pound for pound, it is putting out far more light than anything that young and that small ought to be capable of. Our formation models say early galaxies should be dim, ragged, and slow to assemble. This one is compact and burning. So what is powering it? One possibility is that star formation in the early universe was drastically more efficient than we assumed, that gas collapsed faster and converted into stars with almost no waste. Another is that the first generation of stars was so massive and so hot that a relatively small number of them could outshine an entire modern galaxy. Another is that something is feeding at the center, an early black hole pulling in material and radiating as it does. Every one of those explanations requires us to change something we thought we understood. But the brightness is not even the strangest part. When the team examined the spectrum in detail, they found the chemical signature of the gas inside this galaxy, and the ratio of nitrogen to carbon came out high, unusually high. That matters because heavy elements are not free. The universe was born with hydrogen, helium, and a trace of lithium. Everything else, the carbon in your cells, the nitrogen in your DNA, the oxygen you are breathing right now, had to be manufactured inside stars and then thrown back out into space when those stars died. Enriching a galaxy takes generations of stellar life and death. At 280 million years old, there should barely have been time for one generation, let alone enough to build up that kind of chemical imbalance. And there is a second layer to it. We see this same nitrogen-rich signature somewhere else, in globular clusters, the dense, ancient spheres of hundreds of thousands of stars that orbit the outskirts of galaxies like ours. They have always been treated as relics of the early universe, formed sometime in the first few billion years. If MOMSI 14 is already wearing that same chemical fingerprint, then whatever process builds globular clusters may have kicked off almost the instant the fog cleared. That does not adjust the timeline, that compresses it. You could file all of this under one weird object and move on. Outliers happen. Nature produces freaks, except this is not one weird object. Since Webb began operating in 2022, it has been returning the same result over and over. Galaxy after galaxy in the deep past that is too luminous, too grown up, too enriched, too structured for the moment we are catching it in. What was supposed to be a handful of exceptions has quietly turned into the standard finding. Our framework for how cosmic structure assembles was not sketched on a napkin. It was built across decades of observation and simulation, and it has survived an enormous number of tests. It is not simply wrong, but it keeps being surprised, and a model that is continually surprised in the same direction is a model with a hole in it. Maybe dark matter seeded the first structures far more aggressively than we have accounted for. Maybe the physics of the first stars is different from anything in our catalogue. Maybe there is a mechanism operating in the first 100 million years that we have not imagined yet. That is not science failing. That is science doing exactly what it is supposed to do. Running into a wall and refusing to look away from it. And the record will fall again. Not if, when. There is another anomaly sitting in Webb's deep field data, and it may or may not be connected. When researchers went through the deep images and sorted spiral galaxies by which way their arms wind, which tells you the direction they spin, the count came back lopsided. A clear majority appeared to rotate the same way. In a universe with no preferred orientation, that number should land close to even. Half one way, half the other. There is no obvious reason for the cosmos to have a favorite hand. The study's authors raised a possibility that sounds like it belongs in fiction. What if the imbalance is a residue of the conditions our universe was born in? What if our universe is sitting inside a black hole? Follow the logic, because it is more coherent than it first sounds. When enough matter collapses under its own gravity, it forms an event horizon, a surface that light itself cannot climb back out of. Cross it, and you are gone from the perspective of everyone outside. What happens beyond that boundary is genuinely unknown. Our equations hand us an infinity and stop being useful. Black hole cosmology takes that gap and fills it with a proposal. What if the interior is not a dead end, but a region of space that expands? What if everything we call the observable universe is what a black hole looks like from the inside? Now go back to the beginning. The standard account says the universe started as a singularity, a point of unbounded density, which is precisely the description we give to the center of a black hole. Under this reading, the Big Bang was not an eruption into empty space. It was the far side of a collapse that happened somewhere else, in some larger parent cosmos, when a sufficient amount of matter fell together and sealed itself off behind a horizon. And if that is true once, it is true everywhere. Every black hole spinning through our own sky would be the outer wall of a universe of its own. It even offers a strange answer to why the constants of physics seem so precisely tuned for a universe capable of holding together. If universes reproduce through black holes, then the ones whose physics allows black holes to form are the ones that leave descendants. Selection at cosmic scale. Supporters point out that the numbers rhyme in suggestive ways. Black holes carry staggering entropy, which is another way of saying they encode a colossal quantity of information, comparable in scale to the information content of a universe. Then there is torsion. In extended versions of general relativity, such as Einstein-Cartan theory, space-time can twist as well as curve, and that twisting responds to the intrinsic spin of the particles inside it. At ordinary densities, the effect is undetectable. At extreme densities, it may become dominant and repulsive. If that is right, a collapsing core never reaches a true singularity. It compresses until the twisting shoves back, halts the collapse, and reverses it. A bounce rather than a point, and what looks like an ending from outside the horizon looks like a violent expansion from within. That expansion is what we would experience as the Big Bang. Not something from nothing, a rebound. There is a quieter explanation available, and honesty requires putting it on the table. The rotation asymmetry could be an artifact. Our own galaxy is moving, and that motion subtly brightens objects, turning against our direction of travel and dims those turning with it. If our estimate of the Milky Way's rotation is even modestly off, a real bias could appear in the data where no cosmic mystery exists. The same caution applies to MOAM Z14. Small samples deceive, early measurements get revised. Some of what looks impossible today will be unremarkable within a decade, but that is the honest position. Not that the universe inside a black hole is proven, and not that it is nonsense, but that we are standing in front of several unrelated pieces of evidence, all pointing in an uncomfortable direction at the same time. A galaxy that formed too fast, chemistry that arrived too early, a sky that appears to have a preferred direction. 13.5 billion years ago, that light left home carrying a question we still cannot answer. It has been traveling ever since, patiently waiting for someone to build a mirror wide enough to catch it. We finally did, and the first thing it told us is that we understand less than we thought. What do you think is really going on out there? Leave it in the comments and stay with us here, because today the space world just got stranger.